All right, hello. Welcome to Night Chemistry, October 29th. It's the first day of chemical equations, or balancing chemical equations, or balancing chemical reactions. I don't care which way you want to head it, but that's one way or the other. That is the title for today's class, Night Chemistry, Chemical Equations. So today's due now, I'm about to show you in a minute. I'm kind of lay out a rundown for things first. Basically, a little preview of how this is going. In the beginning of class, you would have walked in, students all walked in and received this worksheet. Okay, this worksheet begins with actually some notes that we touch on, some practice problems on the bottom of the second page. See, page 2. And then some more notes that we flip through on this day 1. We finished this on October 29th. This whole page has basically been assigned or finished, and then assigned that bottom of page 2, those 4 problems, to balance those. And then what was handed out was this page. This is what I'm calling a strategy page. So the strategy for balancing chemical reactions kind of gives you a little flow chart of things, and then on the back side are a ton more problems with really higher level things. They're going to come, more tips will come along the way, and of course I have some tips that I display in class, and I'll mention those for you as well. But those are the 2 worksheets handed out as of class on October 29th, so you can get yourself squared away. So you can be squared away and feel good about it, feel confident about it all. Anyway, so that's where we went today, October 29th, and I'm about to show you the do now, and we're going to go from there. Oh, hi. Yeah, you just caught me coming from the back, the back of the office over there. But here I am, just going to teach you some things, going to show you what's up in our what's up for the day. Take a look here and see. Just coming to you from the office, Anyway, so this is our due now for October 29th. Oops, it's going to go. There we go. This is our due now. And I asked you to write the chemical equation for calcium hydroxide, AQ, meaning aqueous, which reacts with phosphoric acid, aqueous, and aka hydrogen phosphate. I give you its real name, it's called phosphoric acid, but we learned it, and we would know it as hydrogen phosphate. That's how we could recognize it. Anyway, to produce calcium phosphate in water. This puts into practice the writing chemical formulas from the names, which was what we just did in our last unit. And then balance with coefficients, of course, so that's that. And then rewrite another one and predict the products and balance this reaction. You can see as it's written. So take about 4 or 5 minutes, attempt it on your own. And then I'm going to go over some things on those in a moment. But once again, that was for you just to kind of trouble with on your own, try to troubleshoot, think about, consider the ways that it could be one way or the other, and try to solve it. This is just using bond writing techniques from earlier, now just in the next step, the next iteration step. So pause right now, try those on your own, and then the key is coming, so do it. Be honest, it's how you're going to learn the best. Thanks. Okay, so next up is the writing of those, is the checking of your do now. So close your eyes if you hadn't paused yet to check it out. Anyway, we see here that it was calcium hydroxide with phosphoric acid, which is hydrogen phosphate. So there it is. To produce calcium phosphate. So all we've learned here that's new so far is that when it says reacts with in words, that just means a plus sign in between it. When it says to produce, that means we use a yield arrow. And if it says and, that also means a plus sign when you're writing these chemical equations. It's a chemical equation, and the whole point is balancing it. The reason why we balance chemical equations is to demonstrate actual chemical reactions in real life, which shows the law and represents the chemical reaction as demonstrating the law of conservation of matter mass. So that's why we balance it, so that things are representing that adequately. There we go. So that's the problem. That's calcium hydroxide. Got it filled out. Calcium brought 2, OH1, crisscross. You got it written that way, actually. Then hydrogen brings a 1, phosphate a 3, crisscross H3PO4. Calcium brings a 2, PO4 a 3. Brings down. When I say it brings it, that means it's its oxidation number. We get those oxidation numbers from our rainbow pack periodic table. And then H2O. Now I have a modification about H2O and a couple rules to help us follow, which we'll see next. So first one is leave loners last. Now what does this mean to us? What that means for us in this case is to think about this equation. Right now this equation doesn't have any loners, so that's not what we're talking about. We're talking about a separate situation. Oh, here we go. We're talking about, this one is a little bit different mentality. We're talking about this, we're talking about loners last. Oh, wow. That's enormous. Do that. All right. So loners last would be like take an equation like this, Na plus O2 yields, I want to write this on the next line, Na2O. Okay. Bottom line is here we see that sodium would be considered a loner. Why? It has no subscript, has no partner. Why is oxygen not a loner? Well, technically it's kind of acting alone-ish, but it's bonded with itself. It's O2, it has a subscript. So it's got a chemical compound. Once again, Na2O is a full compound, neither element is alone. Sodium is alone, it's considered a loner. Balance the loners last. Just a good strategy. That's my strategies for winning and being successful on this. Treat polyatomics as one whole. What does that mean? That means look at OH. Oops, let me get rid of my writing here, sorry. Oh, get rid of my writing. Notice OH here and PO4. Those are polyatomics. So those ones you need to deal with as one whole thing. Now you might say, well, where'd the OH go on this side? Well, I'm glad you asked, because the next step is turn H2O into HOH 90% of the time for balancing. Reason is, it turns out that writing it as HOH, you get to see actually how you get to see, let me erase this garbage here. Oh wow, gotta go back here. Erase this. You get to actually see it as the ionic format. And you can balance the entire OH separate from the first H. The first H, leading H or front H, and then we have OH here, OH there. We can treat them as separate entities, separate species in the reaction equation, so it's easier to balance when you do it that way. So that's that. Pretty straightforward, pretty simple. Next step is to balance it, and so let's use those rules. Start with the polyatomics as the next rule. Start with polyatomics. That's what we're going to do next. So, starting with polyatomics, we start with the most polyatomic, which is PO4, because there's 4 O's and 1 P. It's 5 items in the species. So we start with that. We see that we have this 2 outside the subscript, gives us 2 PO4s. So we need 2 PO4s over here. There's 1 right now as it exists. So we need to put a 2 there, which of course makes 2 PO4s and 2 H3s. Or 2 times 6, 2 times 3 is 6 leading H's. That's H's out in front. So since we wrote this as HOH, we count only this H here, and we need to have 6 of them. Which makes our H's work, but now we gotta change and make our OH's work. 6 times 1 OH here. I have 2 here. I need 6. So 3. Which makes there be 3 calciums, and there are 3 calciums, so I can put an understood 1 there. I want to put the 1 just out of practice because it'll help me verify and work with all different types of problems, but understand that it's an understood 1 for the most part though. Okay, so if it's missing and there's only blanks to fill in, I'm not going to count off. But if I ask like, okay, what are the prefixes to fill in, or the coefficients to fill in, and I just list the numbers, 3, 2, 1, 6, you need to know that that's what's pulling these numbers out. Okay, so let me cancel that. And here's our final answer with some green font. Make a note, ask questions, check yourself, whatever it may be, but don't let the moment slide by. All right, next was a predict a reaction. So we take iron 3 oxide, and iron brings us 3, oxygen 2, swap. We should have a plus sign here. I guess it got erased. Zinc brought a 1, sulfate a 2, crisscross. And now the question is, what are the products going to be? Well, in the last reaction, notice we had Ca with OH and then H with PO4. And then on the other side, we have Ca with PO4. So Ca left OH and got with PO4. What would be understandable is that if H left PO4 and got with OH, and looky there, it did. So the way we would think about it in these terms would be something like, they'd be like, this is like the first cation, and this is the first anion. This is the second cation, and this is the second anion. So in very basic number terms, we would say that this worked. So this was the first 1C, this was 1A, this was 2C, second cation, and 2A, second anion. And so they re-merged and went 1, 2. So 1C got with 2A, and 2C got with 1A. See how that works? 1, 1, and 2, 2 swaps. 1C and 2A swap to each other, and 1C and 2A, or excuse me, 2C and 1A. So basically 1 with 1, and they swap partners. Anyway, you can see how that might work. If that's how that happened on this one, why couldn't we predict that this also would happen that way? Well, we can. We can predict it that way, so we will. And these are the products. Fe with SO4, check. And zinc with oxygen, check. And we, of course, are still swapping on that one. And then we need to balance it. We see here, oops, there should actually be a 3. It's not written. It should be a 3 right there because Fe brought the 3. It should swap down. And then it's just to balance it. Situation, we have 3 SO4s, so we need 3. Also missing a plus sign. So we need 3 here. Treat the polyatomic as a whole. That makes 3 SO4s and 3 times 2 zincs. So I need to get 3 times 2 zincs, 6 zincs. Also, that makes 3 O's. Yeah, there are O's already in here, but we counted that as part of SO4, so we don't need a double dip. 3 O's, O8, 3 O's, so 1, 2 Fe's, 2 Fe's. It's 1, 3, 1, 3. Track it? Good. That's how we started off the class period, and we talked about these rules again. Have you repeat it, leave loners last, leave loners last. Treat polyatomics as a whole, treat polyatomics as a whole. H2O to HOH, I don't repeat that one. It's for 90% of the time, though, I say, because on combustion reactions, it gets a little bit more finicky. And then we start with polyatomics to do all of our reaction. We don't have to count all the numbers of elements, and we do that to save us on multiple fronts. So it's just kind of just a quick strategy. These are all my strategies. These aren't necessarily rules per se, as much as they are, oops, I'm getting the wrong one. As much as they are just quick strategies to make things work better for you. Anyway, let's keep going. So that's our final answer, as we saw earlier. And the rules again. Then I had students look at this problem again, and with subscripts in the teal there and then the black. That tells you the state of matter that the compound is in. Notice aqueous, solid, liquid, gas, 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 and this is technically vapor, but it's been erased. And then I had students work on this one, balancing that one. It's a little bit more difficult, and this brings up an interesting other rule, a fifth rule, that any reaction where there's only carbons, hydrogens, and oxygens, or CHO, CHO, let's go. I emphasize the ending of O as with like an H sound because you start with the H's. And then you work on the C's, and then you work on the O's. In any CHO reaction, it's called a combustion reaction. And because of that, on combustions, you don't have to rewrite H2O as HOH, just leave it as H2O. So in doing that, let's balance it. Starting with the H's, we gotta go with 4. Oops, gotta go with 4. Which, nope, excuse me, that is not right. There are 2 right now. I have 3 and 1 is 4 over here, so I need to write down a 2 right here. Which affects the oxygens, but we put a pause on that. Because the next things we work on the CHO, let's go, is C's. 1C, 1C. And then we look at the O's. If there's a 1 here and 2 O's and a 2, that's 4 O's total. I've got 2 and a 1. There's not going to be an easy way to go to make that work, except to make this number of O's, this number of O's, an even number. So make it a 2, which makes C, 2 C's, which makes 2 there, which makes a, into 2 C's, that makes 6 and 2 more hydrogens is 8 hydrogens. So I need a 4 here. 4 oxygens plus 2. So it's 4 makes 8 oxygens. Oops, 8 oxygens. So I need 8 over here. I've got 2 already. I need 3 times 2 more, 6 plus the 2. 2 here times the oxygen makes 2. I need 6 more to get to the 8 total oxygens. Does that make sense? Okay, good. And this is what it would look like. Write down any questions you might have. That's just a weird strategy one. It takes a little bit more processing to do it, but we can do it. Oops. Then I had students look at these equations and repeat the process. Let me get rid of my text there. All right, so that had you repeat the process. So this one was about 4 or 5 minutes long of waiting. So pause, go try to balance these on your own in your own notes on the worksheets, which, by the way, those worksheets at the very beginning I'm going to attach to this with this video. So get after it. Let's go. Go Dogs. Balance those worksheets. We're going to go over them in a second. All right, well, it would seem... Anyway, there's one worksheet I can't seem to find the digital copy of, so I'm going to have to do it this way. I'm just going to hold it up to you. Oops, got to move my blurred background. Oops, got to do this one. Sorry, y'all. This right here is, you know, I'll have to get it to you physically, hopefully at some point. Anyway, I'm just going to take a little picture of it somehow and upload it myself. All right, this is what I call the strategy worksheet. It gives you a little strategy for doing chemical reactions, balancing them, and writing them. A little flow chart, and that flow chart that's in the middle there is blown up. For you there. So go back, pause, take a screenshot, take a look at it. It's just a strategy page. I can give you a physical copy whenever you're here next. So, just for the record, I want to make sure that that is cleared up, clear as mud, for when we go further, or when if I refer to it. It's called the strategy page. On the back side of the worksheet that I've assigned is going to be uploaded with this video on Google Classroom. So don't fret, worry not. And anyway, balance these equations. Check it out. Next one. Oops. We said we start with RB. We leave RB last. We start with S8. We make 8 here. Makes the S good. 8 times 2 makes 16 RBs. We balance it out. Then we have, same here, NA, leave it last, 2 CLs, so we put it there, which makes the CLs good, but also change the NA. We put a 2 to match. Then, same the loaner, we see L, put a 3 to make the CLs good, makes 3 LIs, put a 3, 1 there, 1 in front of the AL, because the ALs are good. All right, this one was a little bit more tricky, but it still ends up pretty simple. This one you use similar strategies that you would do for the Cho problem. You do the H's first, or similar strategy that you gotta just try something out and go with it. So here, let's go. This one first has us do. Let's see, the way you first would start out with this one is you'd look and do C's last. So don't do anything with a C. Don't do anything to the C's yet. So first see that there are 2 S's, so we put a 2 there. Then that makes 4 O's, so we put a 4 there. 4 there. Which then makes 4 C's plus a 5th C, and we put the 5 there. Just systematically go. Still loaners last, actually. That's pretty much that problem right there. And then, so I remind you of the rules for only Cho. Let's go HC. That means you do. You start off with balancing the H's first, then the C's, and then really you go a little bit further. Let me move my picture here for you to see it. Is you go further here, and you go HC to balance, then do O's, and if you're still not good, you can try doubling your numbers. All of the coefficients you did for H and C. Double those numbers, then go back and try to find O. If that still doesn't work, you just kind of guess and check a little bit. But more or less, the doubling it almost always works because you're usually just off by a factor of even versus odd. So should get you there. And anyway, that's how you do those. Next, I would just release you to do those problems on the notes. From the notes I just slid aside, I don't have them with me in front of me. Oh, there they are. The notes, I would have you just to go ahead and do those 4 problems on the bottom of page 2. And then I did release the students to go and work on the back of the information page there, the strategy page. I had you work on this, and I was around to answer some questions here and there. But that just kind of takes you full circle from where we're going, from where we are to where we're going, gets you squared away. That's what we did in class for October 29th. And the rest of the class, we just use that to work time. So work on those problems. Best thing to do is, if you have any questions, is to try it out. Send me a picture and say, hey, am I on the right track here? Am I doing the right thing here? In which case, I will be able to respond and tell you, probably I diagnose what issue you might be on or what's going on with the problem itself. So that'll cover that base. Now there's one other feature I need to tell you about, and that's really where the slides are that you should view, and kind of make sure you're already you're aware that you can follow along watching the videos, of course, but you can also look at the slides yourself, get ahead, and then basically it's a very short section. It's like a subunit that builds off of bonding and connects us into the next more difficult heavy unit. So I'm going to show you where those slides are coming very, very soon. Next. Okay, so you go back to on Google Classroom, you could find, you got to get to our slides. Of course, I'm going to navigate you there. I'm going to fast about it because I've done this 100 times at this point. But you can find your slides on the Class Drive folder in Google Classroom under Classwork. Also, you go straight to Google Drive, and it should be in their Shared With Me section. It should be in your Shared With Me section. Or if you pinned it, if you first time you went to my Shared With Me section, you could have done Add Shortcut under this drop-down menu, and it would be in your Drive under your regular Drive portion. Of course, I own it, so it's going to open a little bit differently than yours. But once again, you go back to you're in the Google Classroom, and ours is through resources, class docs folder. It's just the easiest way to go about getting it. So you click on this mug right there, that link. Mine has happened and gone away. And you're going to click on that folder. It takes you where you need to be. Now, I've updated all the slides. They're streamlined to what you need and only what you need. There's a little note at the very beginning that you can read. It says basically the first 10 slides, or slide 2 through 10, cover some things, remediation type thing. It's what I did not from a course. But it's quite comprehensive. I'm not big on that content. So anyway, it'll bring you to this. We're in the Balancing Equations folder, and then those slides are chemical equations intro. I updated it today, so it's good. Slides, and beginning on slide 11, note on slide details are really for remediation. If you want the remediation, please contact me. I can get you a digital copy of that file to be able to do those slides. Early slides, once again, to remediate. If you've never had those slides before, and you have no concept at all going on, especially, this would be one way to orient you. Slide kind of the money, the that what we're doing, they don't have to, but that's okay. You just need to put on important, just the content. I'll just continue on from end all the way through the end. I'm not going to play them right now. I'm just showing you how to get to them. These are the updated slides. This is exactly what we're going to look at. 5 types of reactions, 5 plus 6-ish, whatever, indicators of reaction. You should get a load on all of those. I'm going to go ahead and skip straight to slide. I guess 2 through 11 is what you skip. Yeah, 2 through 11. I didn't say it that way, but start with 12. That's the one we did in class. Balancing equations. I keep on going through the rest of it. 12 through the rest. That's just what you should do. So take notes on all that stuff. Let me know your questions. Got to get to it. Tomorrow we're just going to finish those notes. Basically, we're going to finish those slides on Friday. That's October 30th. We're going to do some more of those balancing practice. I'm going to hand out another worksheet. And we're going to kind of prep for lab, because we're probably going to do lab Monday or Tuesday. And I'll try to do a demo, but we'll probably do a lab Monday or Tuesday. I'm not doing another video for day 2 for chemistry. This is basically chemical equations. Actually, I might do a day 2 video. Anyway, it might just be me going through the notes that we do in class on Friday, which is, once again, I'm rehashing what the types of reactions are again and indicators of a reaction. Now, I say rehash because in class I also, I forgot I didn't do this, walked through this worksheet, which goes from a definition level, the notes and the practices on page 2, which I have not done yet. So there are the slides. A re-encapsulation of everything. You need to take a look at it. You need to get it done. It's actually this way on my video. So get that stuff taken care of. I'm going to close out this stuff, and then we got one more little sub piece that we did in class that I haven't done yet for you. That sub here, it is the reactions notes. I just basically walk through this. Chemical reactions represented by chemical equations, demonstrate the law of conservation of matter mass. I make that into a phrase that everybody repeats over and over again. And then I say they consist of, to the left of the arrow, or to the, well, what's left to you right here? This is left. To the left of the arrow are the reactants, and I highlight those, and I say the left are the reactants, and everyone says it. Then to the right side are products, are yielded. Reactants not going to, becomes, it changes into. Reactants yield products. Little subscripts G, L, S, and AQ are described there. It just tells the state of matter. They really have no value for balancing. They're just there to add more information. Then we go through how to write and balance a chemical equation, in which case I walk through the solving of this problem. I will for you as well. Remember, it's CH and O is present in this, so CHO, let's go. So we start with the H's. Go. Start with the H's. We end up having, we need to make 8 H's, so we put a 4 right here. We leave the O's for last, so we look at the C's. We go 3 here. Then we look at our everything. 3 times 2 is 6 O's, and 4 is 4 O's. 6 and 4 makes 10, so I need 5 over here to make it 10 oxygens, and we're good, because 10 on either side. Now, if it gave me an odd number, like this was my oxygens on the right side added up to be 11, perhaps. Well, 2 times what doesn't give me 11? There's 2 times 5.5, but I have to use a whole number. So if that happens, then what I need to do is double everything. In fact, this is the coolest thing. I can put the 5.5 in the place right here where the oxygen is, and I have an understood 1 right here, and if I double everything, it would work out. I'd put a 2 instead of a 1, an 11 instead of a 5.5, a 6 instead of a 3, and an 8 instead of a 4. That's if I had to double it. Right now, I don't have to double it. The 5, 3, and 4 makes it balanced, so we're good to go. But I just want to make sure I told you that when you go to some of the other CHO problems that you know how to go when you let's go. It's one way is the double it method. That's part of Rule 5. Okay. Question then, the notes just then take the student through the process. Is it balanced? Use coefficients. Never change a subscript. Check its balance as you go along. Recount as you recount. You don't have to necessarily. And then it goes through 4 practice problems for you to try on your own. Do those. Those are the first 4. They're due next Tuesday. In class it's 11:3. But tomorrow we're going to kind of discuss these a little bit, so it's helpful. It's most relevant to have it done by tomorrow. The rest of the notes goes through this reaction types. There's 5 types of reactions. I say to everyone, I would say there's 5 reaction types. 5 reaction types. Type 1 is the synthesis. It's A plus B makes an AB product. Everyone so said type 1 synthesis. Type 1 synthesis. A and B plus B makes an AB product. So we see here NH3 is the A, HCl is the B. Combined all together is the AB product. H is the A, O2 is the B. You get H2O is the AB product. Same here. Next one is decomposition. I said type 2. Decomposition. Take an AB reactant into an A plus B product. So that's decomposition. That means to break apart. It's the opposite of synthesis. So we see here an AB reactant makes an A and a B product. Reactant makes an A and a B product. Listen to that again, because I would repeat it in class. Just replay that. Go back a couple seconds and re-listen. Next one is single displacement. We take an A and an AB, or an A and a BC, and you get either an AC and a B product, or you get an BA and a C product. The thing that gets swapped matters, because if the anion swaps to a cation, that means you have 2 anion possibilities and they just swap places. Such as in this case, Cl2, if it weren't in a diatom, if it were in ionic form, in the reaction would actually form an anion. So it would swap with the anion of the ionic formula. It'd swap with Br. And it does. It swaps with Br. Which means Br becomes the anion as well. Cool? Or still an anion, but swaps, places a single displacement. You have the A species, you have the BC becomes a B, A, and a C product. Now in our PowerPoint, we actually see a different situation over here. We see that lithium is actually an A cation, and there's a BC compound as a reactant. Forms a, let me close this out. Go away. Forms a C product and the B product as well. So you can see that swap around. Once again, This was an A and a BC, and it becomes an AC and a B. That's different from the other one, which once it shows an A with a B with a A with a BC, and it becomes BA with a C. Go back and listen to that if you need to rehear it. And we'll say type 3, or that was type 3, single displacement or single replacement. Type 4, double displacement, aka double replacement. This is where you have a 1 and a 1 and a 2 and a 2 and a 2, cation 1, anion 1, cation 2, anion 2, swap places. So cation 1 goes with anion 2, and cation 2 goes with anion 2 or 1, and they become a new product. Notice AB with CD becomes CBAD. Another type of swap. Type 5 is combustion. It's always a hydrocarbon with an oxygen, forms the products carbon dioxide and water. Always the same products, CO2 and water, always the same products, always the same reactant, oxygen, and then it's some form of a hydrocarbon. It gets more specific as it goes for the general form of a combustion reaction. And those are the ones, that's the CHO one, where we do let's go. Anyway, last bit of notes that we'll cover after this, that was all we covered in class, was the rest of that page. I assigned bottom of page 2 and that worksheet on the back of the strategy page. You'll see that, it's called chemical equations number 6. Those are all uploaded, they're all there. Get the stuff done, get your questions, let me know. Let's go, have a great weekend. If I don't post a video tomorrow, go Dogs.